The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from Hawaii Tracker, and also H. Very, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, August 17th, 2023. We're bringing you guys another Hawaiian Volcano Tracker update. And we still understand that there is a lot happening on our neighbor island of Maui. Slowly unfolding tragedy still. Or I suppose the impact is slowly unfolding, right? The tragedy has occurred there. How you been riding through this, Dane?
I've been, as good as anybody, I guess. Hard to watch. The more you find out, the more frustrated you get, essentially. But yeah, it's not going to be the focus of this. What we're talking about here is back up at Kīlauea, and yep, we're just going to continue doing what we do. All you really can do, and eventually maybe it'll be appropriate to talk about some of the things on the Maui communication side of things, but that time isn't really right now. It doesn't feel appropriate yet.
Yeah, it's still really unfolding, and it's not really our intent to like throw fuel onto the fire or anything like that. Right. But we certainly can say early on that we do see a lot of parallels to what's happening there and what happened in 2018 here in Puna. And we'll just leave it at that.
Yep.
Yeah. So that time and that day will come. Otherwise, here we are on Hawaii Island. Kīlauea is still not erupting, Mauna Loa not either, but we'll cover the rumblings within them both today, as usual. Dana will be leading discussion on the chat, collecting questions as we go along. Anything else you want to throw in here, Dana, before we get into it?
No, I think that's it. We'll be in the chat and get to the questions later in the program.
Oh, that sounds good. So let's get into our Hawaiian volcano summary here. So for the Hawaiian volcano summary this week, starting off showing you guys a live image of Kīlauea, which is still quiet on its surface, no lava on the surface, but still fuming, putting out a little bit of gas. Gas levels are pretty low still, but still affecting the nearby communities. Still the lowest amounts of gas that the volcano has put out in quite a while, and thus the VOG impact is less than the usual. Right, there it is, the view further to the east on Kīlauea there. The story, though, on Kilauea this past week has really been the increasing number of earthquakes. So these are earthquake rates for the past month in Kilauea. So the past week is about this chunk right in here. And you can see this increase in earthquakes.
Sorry.
Way back. All right. So these earthquakes here. Maybe I should start it over here, huh? So in Hawaiian volcano summary for this week, the story on Kilauea is increasing earthquakes over the past week here. And you can see here on this plot for the past month of earthquakes that over the past week here, this chunk right in here, the earthquake rates have really, in this graph, more than doubled. You can see the values here. This is the whole Kilauea summit and South Flank and Pahala region. But those values were down around 30 to 50 earthquakes per day for much of the early part of the month. And just here in the last week or so have increased to in the range of 150 or so earthquakes per day. Within Kilauea summit itself, USGS reports that the numbers were more like 20 earthquakes directly below the summit, increasing to about 40 below the summit. However, just yesterday, there was an earthquake swarm of 50 earthquakes. So you can see that the values are proportionally also increasing as well. So we'll just keep it at more than doubled here over the past week. And that corresponds to the ongoing inflation and swelling of the volcano. So Kilauea is still pressurizing, getting ready to erupt. The USGS has increased their updates back to their daily frequency in anticipation of some potential event happening, stating that the volcano is not showing any signs of imminent eruption, but that it could increase its activity towards an eruption within a fairly short amount of time. Here's what the earthquakes look like on a map view. This is Kilauea summit right here, where all the earthquakes are concentrated. It's important to state that the entire rift zone of the volcano is all very quiet, and thus no unusual activity in either rift zone and no threat to people or populated areas around the volcano's rift zones here. However, there is still adjustment at the south flank, but most of the story here is Kilauea summit, the combination of which has been all these shallow earthquakes, colored in orange here on this plot, but also this one larger earthquake of 4.3 that occurred on Sunday. That's much deeper, perhaps an adjustment to the growing building weight within the crust up here. That's this magma that's growing towards an eruption. But this one is actually colored blue because it's much deeper down and disconnected from this upper cloud of events here. So this one fell island-wide, of course. It gets people's alarms ringing here, but that one was not one of the ones that was breaking magma towards the surface. It was more an adjustment below the volcano there. That's the main story on Kilauea. We're still waiting to see what happens next. Whereas on Mauna Loa, it's been pretty quiet still. But the storyline this past month has been these deep earthquakes. This is a plot of depth against time here for the last month of earthquakes around Mauna Loa summit. And it's this deep band right in here that we've been interested in seeing that was more frequent about a month ago, and really in the last couple of weeks has become more sporadic here. Still occurring infrequently, but slowing down and still of interest because, as we noted last week, these are events that often correspond to the injection of magma into Mauna Loa's shallower magma storage system. And so we knew that that was happening already. The volcano continues to inflate, but importantly and differently from Kilauea, this upper band up here, where all the shallow earthquakes would appear, is all very quiet on Mauna Loa. And so Mauna Loa is still very quiet and nothing unexpected happening there. And that's the Hawaiian Volcano summary for the week. And with that, we can switch over to look at our volcanic hazards. which will start off looking at the VOG, right? The biggest impact of the volcano right now is still the gas being emitted. So coming to the School of Ocean and Earth Science and Technology at Manoa, VMAP, VOG Measurement and Prediction Project. Here we'll look at their forecast. And let's get this playing here. Our current emission rate from Kīlauea, reported by the USGS, is only 86 tons per day. So that's fairly low for volcanic standards. Still high for EPA standards, for example. If this was an industrial operation, that would be pushing the limit there. But for Kilauea, a very low number. So you won't see anything colored on the graph here. All these colors of reds and oranges are not really showing up. You only see this kind of gray, where this very low emissions might get blown around and mixed with incoming moisture and weather as well. So looking good as far as VOG this week on Kilauea. If we do, or should we say when we do eventually have an eruption at Kilauea again, that's the time when it gets the worst, is at the beginning of an eruption. So in these lulls is when we have our clean air and we enjoy it for now. And at some point that we'll get another burst of gas from Kilauea, but so far so good for now. Likewise, if we look at the Purple Air Citizen Science Monitoring Network across Hawaii Island, everything is pretty much in the green. A couple anomalous points here and there, but much better than we've seen it as well. So still the primary threat for the volcano is the gas, primary hazard here, but not much to worry about. That's out of the usual, right? People who live on Hawaii Island are fairly used to some low levels of gas, and so that's where we are at the lowest levels of those. Okay, so now we'll jump right into the earthquakes. So let me put up our earthquake map here and show you guys this USGS site for the entire island. And this is now looking at earthquakes over the past 7 days, the past week. You see that there are a few of these events that are farther out. Northeast here, 2.5 at 5 miles down off Honomu, at 1.9 off Lapahoihoi. These ones are a little bit shallower than we typically see for these flexure events, but those are really like a giant stack of magazines, for example. At the very bottom can move, but anything further up can also move. So I put these in these same kind of settling and background events that occur surrounding the island. There is some a little more interesting here to the south. There's one just off Kilauea south flank that's coming up at 2.4. This one is a very deep one, though. And so that's likely one of those adjustment settling ones. All the way out here, 3.4, 27 miles down as well. So another one of those adjustment ones, deep, deep down. And the other one I wanted to point out is this big one right in here. That's the 4.3 that occurred back on Sunday, 15.5 miles down. So those are the deep ones there. Otherwise, you can see Mauna Loa's got a little bit here. Close to the surface, 2.4 at Honau now. A couple deep ones here under Mauna Loa, some at 22 and 25. Off to the northeast, a couple of shallower ones on the east flank of Mauna Loa. But all of this could just be adjustment to just a filling. But really all the action is happening here in Kilauea, which is this bunch of earthquakes all in here. There's another background one up by Hilo 2.2, 12 miles down. I haven't talked about the Hala cluster. That's all the feeder source all through here. So that's all the magma coming in deep down. These are all deep ones. And then moving in some manner to feed the volcanoes of Kilauea, Mauna Loa, and Volcano Loa, formerly known as Loihi over here to the southeast. So we'll really zoom in on Kilauea here and focus on those. And so we noted the deep one there and a deep one up here. The other big ones, there was a south flank earthquake 3.2, close to Napau crater there at a depth of 3 miles. So right in that upper part of the south flank there. And then further over 1.8 and 2.3, that might have been little consequences of this entire piece of land moving as well. But it seems to be a fairly slow adjustment. You're not seeing anything happening in the back end of it up here in this direction. So just normal background south flank movement there. And really all the action is zoomed in here in the summit of Kilauea. So if I do that and come in, you can see that there's a few events over here towards the southwest that we typically get as the summit area seems to swell and expand and kind of push in some direction. So I might be doing some of that. It's hard to tell exactly what's happening there. So focusing on what we can see, there's a closer pattern. You see is actually somewhat of a lineation coming in here, at least on this right side. It seems to correspond to this south side of that inner caldera. right? The outer caldera we've mentioned before can trace all the way out to here. So they're really all within this main caldera area, and perhaps getting into a little bit the southwest rift connector. However, as we'll see, the depths do vary a little bit through here as you get to the southwest part of this group of earthquakes. Otherwise, feeling pretty well here in a caldera, an interesting little arm that comes off towards Kīlauea here too. So it's not always something we can reliably count on, because these earthquakes might have a little bit of error and might be shifted back and forth. But sometimes they actually do capture the general pattern and essence of what's happening here. So I'm curious if this is something we'll see continue here, or if that'll be something that's filled in as the whole system pressurizes more and more and more and more. Because as many earthquakes as we've seen so far, we still haven't seen nearly as many as we had prior to the eruption in June, earlier this year. So we'll make some of those comparisons in a bit here too. So that's where all these events are. And then off here to the north, I scrolled up all the way up here, that's where that 4.3 occurs. And so not only is it much deeper than these other events, but it's also offset to the north by a good distance here. So let's check that out a little bit more detail. Let me come in first to this. So this is a map from the USGS page that I've drawn some cross sections through. So I've tried to capture this deep earthquake and the shallow cluster together, and A in the north and B in the south here, and pull out well, first this is a time depth plot here. So this is depth and time in this direction. So you can see that there were earthquakes happening in the shallow region the entire time, maybe a little bit less here in this first part of the plot. Then they do pick up, and around the same time as they pick up is when you have this deep earthquake. So there's not really any good correlation there as well. Right? You can see this latest band that occurs recently in the last day or so has getting a little bit deeper events as well in the cluster. But the cross section north to south, A in the north and B in the south, is showing there's a deep earthquake 15 miles down, and then much shallower there is that cloud of events with a little bit of that deeper part coming in today right there in the orange. But that's how separate these things actually are. So it might be, you can see, imagine a magma, let's say the magma is collecting in some way up here, something like that. You keep adding extra material to this part of the crust, and you add more and more and more and more. It might be getting heavier, basically, or it can push down with the whole weight of it, and that might cause some of these adjustments and flexure-like earthquakes down here in the root of the volcano. This part down here is the combination of like that root of the volcano and potentially some of these magma feeder sources. We have examples of magma coming from these areas, possibly much deeper than this, in fact, like during Kīlauea in 1959, when we saw 2 batches of magma come to the surface, one that seemed to be very fast, coming from very deep over the course of 3 months or so. That's not the pattern we're seeing here. But just to note that these deep areas are some combination of both mantle faults that can move, as well as pathways of magma that travel through them at the same time there. In any case, that's all happening far away, and there's not really any big connection there. I just mentioned this because we know that we are all rattled when this magnitude, this was a 4.3, shakes everyone on an island. Everyone feels it, and so everyone's wondering, is that about to cause an eruption? Is an eruption happening? What's changing exactly? So it's hard to say it's exactly unrelated, because it seems like everything is piling in the same area here, but it's not directly connected, if that makes sense, right? It could be like the weight transferring down, but it's not a direct connection to the magma pushing onto it or something like that. So that's how that sits. And if we look at that cross section, looking at just this inner cloud, excluding this deep event, so we can get some better resolution in there, that cross section looks like this. Right, so let me pull it back just to remind you guys. A is here to the southwest, B is to the northeast. So to the southwest is over here. That's this area that has a little bit deeper to the southwest, closer to A. And you see that kind of cloud over here to the right towards B, right, the shallower regions between 2 miles and sea level or so, more or less, right in there. And because it's interesting to look at it the other direction, so let's go A to the north and B to the south. And just look at that little cloud, zoom in on that. There is what that cross section looks like. So we're looking on end, right? So this deeper stuff would be closer to us and other stuff further away. But even kind of looking on the edge of it, you can see that it's fairly well clustered there under the caldera, with a little bit of it trailing off to the south here. And so maybe there's some effect of something trying to move to the south, and that's the area, right? But that's the interesting aspect of what we see there. To me, coming back to the map here, this southern edge maybe showing more complexity, maybe because the south flank is moving off in that direction, as we know it does over here, right? So, but pretty tight clustered underneath the summit right in there. Okay, so just using these upper clusters without that deep earthquake for time depth. There's our time, there's our depth. You can see it was fairly coherent within these upper shallower levels until today, where we start getting a little bit more of these deeper events coming up. So we'll see if this is some change, of some sign of another batch of magma coming up perhaps and pushing along the conduit and pressurizing some faults to cause little earthquakes perhaps, that kind of thing. Or if it's something else, we'll have to wait and see, of course, right? Whether it actually keeps building towards eruption at the current rate, or if that rate picks up, or if it decreases, or what have you. And along those lines, this is a plot of just the raw counts of earthquakes within that area. And going back here to 2 weeks ago, and you can see that earthquakes are happening at a pretty decent rate, sometimes a little faster, sometimes a little slower. But then here, coming in about the 13th, 14th, we have our first flurry. So we have a lot of earthquakes in a day, it slows down a little bit, and we have a whole bunch more earthquakes, and keep happening, keep happening, keep happening, a little bit less, but still happening. And finally here, maybe slowing down a little bit currently as we speak, perhaps, maybe. You can't really trust right into these graphs, as it might be pulling in more data as we're talking right now and shooting off again, and hard to tell exactly there. So pretty dramatic difference in the rate of earthquakes. This is one way to look at it. The earthquake counts over time here. Right? And when it picks up really this steeply, that's really the rate of it going really high as well. So some extra views of those earthquakes in there. I think we can come back to our normal earthquake plots and show you guys what this looks like in our typical view. So Kilauea earthquake data here. All of this data courtesy of the USGS Hawaiian Volcano Observatory. Mahalo to them for putting all this out. And here we have the 1 year earthquake counts for that area of Kīlauea. So here we are on the right end with this climbing ladder, this staircase upwards of events plotted as earthquakes per week now. Right? So you see these, each week has been getting higher and higher and higher. Going back in time, this little lull in here is a period following the eruption in June. This is the eruption itself. This is a buildup to the eruption in June with all these high events that got up to almost 1,000 earthquakes per week. So here we are this current week. We're pushing to 600, looks like. A week's not quite over. It'll add some more days here before this bar is done tallying. So it looks like we won't quite get there, but we're getting pretty close to the previous eruption back. That's January of this year, back in here, where those events were up in a close to 600 earthquakes per week as well, right? But they actually were able to sustain those levels for, look like 1, 2, 3, 4-ish weeks, maybe 6 weeks, 4 to 6 weeks, 3 to 6 weeks in there. So hard to tell exactly. Maybe the staircase coming up and 3 weeks of it up top, right? Something like that. It could still be quaking for a while before anything actually pops, with a caveat that the volcano is changing its strength all the time as it's adjusting and stretching and filling and all that stuff underground. So it doesn't always have exactly the same threshold of number of earthquakes. It could pop sometimes at higher levels, sometimes at lower levels, and this one might be either or in between, or who knows, right? But in geology, we like to look at the previous events as a clue to the future events, and that's what we're trying to do here. And so we do see that pattern that's building. We'll see if it sustains for a while, and then whether it breaks sooner or later. Or one other thing we've seen happen is actually all that pressure cause an intrusion, an injection of like a dike, a blade of lava underground, a blade of magma that doesn't actually up to the surface. And so that could happen as well with lots of earthquakes. And so always a possibility, especially with the south flank moving and creating more space for those injections to occur. We have to wait and see how it actually plays out ultimately. So zooming into the 1 month, this is where it's more dramatic here. Or earlier in the month, we're as low as between 10 and 20 earthquakes per day right in here, right? And then climbing to well, 20 to 40, 30 to 50, and then recently here up to this 150. Remember, this is a whole area including Pahala and all that. So, right, basic pattern like that. We'll scroll it here to our depth versus time of that same area and see where these earthquakes are actually occurring. So blue is the color for the deep earthquakes in Pahala and the ones beneath Kilauea crater. So there they are. You see they're happening not exactly continuously, but in bursts at a fairly frequent rate. So pretty steady all through there, all through there, all through there. Maybe slow down here a little bit, but not a whole lot of difference in that band. Here's that big 4.3. You see it's actually slightly shallower than lots of those other events. It kind of sticks out a little bit as separate. What's more interesting here is the shallow band, these oranges and reds, just like we were looking at last week. The pattern is extended this week. And let's see if I can zoom it in for you guys there. Right there, you see they're actually happening, but they're happening with little gaps in between, little gaps in between. Here's a big burst that start things off. Right? It keeps going and going, slows down a little bit. But what I like to do, I probably have to zoom out again for you guys to actually be able to tell, is just compare even this week right here, where you see a lot of black just because there's so many circles plotted on top of each other there, to the previous week where that's happening, but not quite as much, right? So even the previous 2 weeks to that, you see that whole area. A lot of shallow activity happening, but it seems to have intensified for sure, right in this band right here. And if we scroll back up to our previous plot, that's exactly that same area where the earthquakes are picking up, right? So that's the shallow areas where the earthquakes are adding to the counts, not the deep ones. And let's take it back to the last week. So zooming into the week here. There is just the last couple of days, or even then it seems to be picking up a little bit more than it was earlier in the week. So picking up more and more. And there is that 4.3 in depth time across the entire week. Different view than the 2-week one I showed you earlier. So once again in map view, there it is, that cluster inner with that 4.3 to the north. There is all the rest of the blue dots from Pahala. And also included in there are all these south flank events that are shown right in here. So over 1 week, they're all kind of light patterns. Even the background events like the crustal settling, the deep ones out in here are not as easy to see. But I thought we'd start off by showing you guys some of these maps and cross sections and get some perspective here all the way back to the previous 5 years, if we can get there fairly quickly here. So here's a cross section. There's the deep Pahala earthquakes. Over the last week, there is a deep Kīlauea earthquake and all the shallow ones, how they look. And a slice through the earth. And that said, let's come back to the maps first. So that's 1 week on Kilauea. If we go back to 1 month, it looks like this. So we still see those clusters within the summit. You see an extra little tail coming off to the southwest here, but still fairly constricted within the summit. You see a lot more background events in this zone kind of all around Kilauea, except to the southeast, right? You don't see much on the East Rift Zone, but you do see growing numbers of this background south flank activity right through here. And of course, you see Pahala representing down here as it has been for many of the last several years here. Take it back to the whole last year. It looks like this. So this does include that the last 2 eruptions that we've had here in January and in June, but you can see there is that cluster of summit activity right through there. A little bit of that tail to the south once again, and a little bit easier to see this big cloud of south flank earthquakes, which we talk about a lot as happening just a little bit every week, but here over the whole year, you can see the pattern a little bit easier in that cloud right there. Remember, these ones are colored by depth, so you actually get all these purples in here showing that deeper mantle fault zone. That's that deep southern movement of the volcano, and potential magma pathway as well. And then the Pahala cluster really filling in this entire bottom corner of the map right there. And so to round it out for the last 5 years, throw this up here as well. It's a lot of earthquakes, But the reason I'm bringing up this 5-year interval right now of all times is because we are now past 5 years from the last summit collapse in the 2018 eruption. So all these earthquakes you see on here do not include any of that eruption anymore in 2018. It's all the stuff afterwards and since then, right? So we kind of have a 5-year window of since the eruption happened, what's been going on. And what you can see is a very active volcano still. The entire summit region, you can't even see the map anywhere underneath here, how many earthquakes are occurring all over the place, the entire thing adjusting still. Not only that, you see a lot of the south flank adjusting as well, right? Offshore, there's that whole south flank region through there. You see the purples down in here once again, all that deeper mantle zone and Pahala coming in into blues all through here, covering a map altogether. What's perhaps more visible here is where there are less earthquakes, right? You see this interesting band right through there where this part of the island towards Hilo gets actually less earthquakes. Right? That's just north of the East Rift Zone. All through there. And then also offshore, you get far enough offshore, then you start getting down at background levels as well. Right? So really the earthquakes are really concentrated around the island here in Kīlauea. So good reminder to ourselves, this is something that's interesting to check in on for the first time in 5 years. For the last 5 years, this data has been totally overwhelmed by all the events happening during that collapse sequence in 2018 and the eruption sequence in 2018. So here it is without that for the first time in 5 years. And likewise, we can look at the cross sections. There is a last week, as we showed you guys a little earlier. So let's fill it in to the last month first. There it is. So a lot more in the shallow regions of Kilauea building up there. See Pahala lights up pretty nicely as well. And you see several more of these deeper events off to the side here, right? So this single 4.3 doesn't stand alone. It is closest to this nexus of change right here. But you see this whole zone of these flexure settling earthquakes all the way out as well, right? All the way to here perhaps. For the last year, there it is, a little bit clearer to see that. Look at that pattern. You almost see like a cloud right there, the way it goes like that. And Pahala filling in right through here. There's actually another layer down here of these deep ones. I seem to connect, right? So this might be something that hard to tell exactly. It's getting complicated now. And you see how there's actually a band in the greens. The greens don't really show up quite as much. They're still happening, but they're happening at a slower rate than everything else. So over the course of 1 year, you still see a little bit of a gap in there. Right? And you can see that this blue event that we just had, this 4.3 here, is not the only big one in that area. We actually had another one within the last year, not too far, that's slightly shallower right in there. So interesting to note how there are repeating patterns there. But pull it back to the last 5 years, that's really filled in. Remember, this is no collapse, but you can see the entire volcano, the shallow area, the whole thing moves and shakes all the time, all the way out the entire map, right? The yellow just below that, same, all the way the entire map. The green, more so beneath the center. It kind of seems to tail off, right? It seems to be a little wedge right there. And so less so to the east there, but from Pahala and over, you see that kind of adjustment lower down occurring. And maybe that's some hint of some of those pathways to Kilauea from the hotspot. Hard to tell exactly, right? Down here, this big blue, that's all the cluster of Mauna Loa, or I'm sorry, of the Pahala earthquakes that feed Mauna Loa, feed Kilauea, feed Kamaihua Loa. And as just pointed out here, that same kind of bed of deformation and earthquakes here below Kilauea to the south here. So a lot of structure you can see here, and it's interesting to look at what it looks like since that collapse, right? The collapse kind of was a pivotal moment in time separating what was happening. We didn't want that to influence these summaries. And so since we don't have the ability to kind of select our data ourselves with these interfaces, we just know that today is the day to look at these 5-year plots here. And there's that last one. So depth up versus time will be the last sequence. As I mentioned here, for the last week, within the last few days, it's ramped up quite a bit, right? In the shallow area. Over the last month, you can see it heavier right through there once again. You can see the Pahala earthquakes, deep ones, including the Kilauea ones, happening with some little sporadicism in the middle here. But if we zoom it out to the last year, then you can see that it looks pretty steady, both in Pahala. Pahala's been happening for a long time, steadily quaking as well as all the upper regions of Kilauea. Harder to tell much of the patterns. There's certainly some areas where you have bigger earthquakes and lesser earthquakes and bigger earthquakes, but that's why we look at the counts instead of these depth times for that, because it's harder to pick it out. And just for completeness here, for the last 5 years, it looks like this. Hard to tell much of anything. You do see this little gap in the greens that they have it at that lower rate right through there. And maybe another thing you can see is if we look at, let's say, the blues, for example, the blue dots are kind of small right in there. And they get a little bit bigger through there, and they get bigger through there. And then actually all this whole area over here for the last couple of years, the Bahala quakes have been getting pretty big, in fact, right, as we have all noted, but interesting to see it represented in some fashion on the plot here as well. Okay, so that is the earthquake elaboration that we did for today, given earthquakes are the story, right? This increase in recent events and some context for all of that. What we'll do now is we'll switch it over to comparing this with our other monitoring data. So let's put up our monitoring tag and show you guys the earthquakes along with everything else, and let's break it out by different time periods. So let's look at Kilauea's last week first. And over the last week, here it is, over the last few days, ramping up as we've been mentioning over and over again. And there it is, depth time once again, ramping up here at the right side. And on those plots that here, we have the tilt as well. And so for the last week, you can see that it is inflating pretty steadily, apart from something funny happening right in here. We'll talk about it in a second here. But -6-ish to +7-ish, 13 microradians is quite a lot for 1 week. We've seen it not inflate that much in a whole month before. So there it is, quite a lot happening there. We did have, if I scroll up here, there is that deep event at deep 4.3. And that's that same time period right there that we have this. So what's actually happening here, if I zoom it in, is that this straight vertical line is the station getting jerked and moving because of that earthquake. So it's hard to exactly tell what's happening, but it seems like it actually starts deflating before that. Then there's an earthquake. It continues in inflation, and then it actually really inflates a lot more, right? So there's kind of a couple of ways to look at this while we're here. One is that you could just take this entire area and reconnect it to here, or take this area and shift it upwards, right? So this plot would look something like that normally, and then the earthquake came and shifted it and offset it. So in that case, it might be a deflation-inflation event, something like that, superimposed upon this longer-term inflation. It could be as little as that, right? But what if it wasn't? What if it was something else? Well, then this deflation is perhaps a deflation-inflation, something like that. But let's say that the earthquake aborts that process, and let's say we resets it in some way. So now we're back to a regular. And in that case, if we see one of these bumps that's a unilateral rising up like that, that is our typical signal for what an intrusion might actually look like. So depending on your point of view, your interpretation, and we don't have enough information, like the USGS likely has more and knows what the answer is here. But from our point of view, without knowing further details, this is a candidate for a very small intrusion event occurring here. And I say very small because we pull it out to the graph. You can see it's just one small little microradians worth of it over what for the whole week ends up being 13 or so. So it's fairly minor in the grand scheme of things. But if so, we have had these earthquake flurries and swarms occur during intrusions before as well. So it could be the wedged in somewhere and accelerated the events there for a little while, and then just continues this regular process now, kind of building and pushing and bulging a little bit more and a little bit less, a little bit more and a little bit less, something like that. That's a possibility. But really, more important than that one little bulge and the earthquakes which are happening within that particular little time frame is the big picture of this large, steady inflation here, or the ground tilt. Remember, we're still looking at the 1 week. So over that same week of time, we see here's a lava depth. This is zoomed in a lot. We're looking at between 400.4 and 401.6 meters. This is just 1 yard of difference, top to bottom, on a measurement that's apparent measurement coming through. And this is a cycle we've seen that corresponds to the temperature of the area, right? So there's something going on. This is probably just the range of error, we'll call it for now. As far as we know, not knowing that it's linked to any physical process on a volcano surface itself. Totally unrelated to this inflation event. So there it is, inflating underground on the surface, no sign of any change whatsoever there, right? Zooming out from the last week to the last month, this pattern of lake depth that's undulating there collapses down to this right through here. That's that last week with his little bumps showing that little undulation. The whole thing is kind of blown out on the y-axis here because of this not quite 1 month ago tropical storm Calvin rainfall coming and obscuring the laser and giving us some extra noise here. So likely next week this will get shifted over and zoomed in, and we'll see a bigger pattern here as well. But the more important thing is that we're seeing a very, very slow, gradual settling here. So it's almost flat, but very slightly downwards. Maybe an easier way to convince this is if I zoom it all the way in here. You see we're getting pretty close to the dotted line here at the bottom, only a couple pixels of white away. And back at this end, it's not quite as close there, not quite as close in there. So very slow, but it is still settling very slightly there. So no change in the surface here, but underground, there's the last month of earthquakes. Once again, let's draw this on here. We saw how that corresponded to the depth time. One more time there. And look at that, it actually matches up to our tilt. And interestingly, our tilt for the last month has been inflating the entire time as well. We were seeing more of these deflation inflation events, like we saw a couple through here. A couple of these weird little spikes through here as well. I'm not sure exactly what little variation was causing that. But over the whole month, from -6, 7 maybe, to positive, we'll call it -7 to positive 15. So about 22 microradians in total there. That's quite a lot. But remember, most of that 13 of those were here within the last week. Right, so we're having over half of the inflation within the last month happening within the last week. That's pretty impressive. That corresponds as well to these earthquakes right there, right? So you can see the thing is really stretching out there. It was inflating pretty good there, but now it's really almost starting to bulge a little bit there with that extra rate and the earthquakes popping there. So that's a fascinating thing. It's picked up speed and maybe slow down a little bit, but that's the interesting thing to look is how steep will this rate actually become. You see it's maybe a little flatter, but still rising pretty fast once you average out the little variations here. So this is the Uekahuna station in blue, and I thought we should also look at some of the other tilt stations. This is Sand Hill to the southwest. So also a nearby Kilauea caldera, but just a little bit further southwest. There is a spike from that earthquake occurring right there. It's visible as well. And you see a similar pattern of inflation. Right? So clearly, this whole summit region is feeling it, and it's not localized to that one station. Right? So that's cool to see. And then scrolling down to the East Rift Zone by Pu'o'o, we have a little offset from that earthquake once again as well, but the opposite pattern. The thing is still deflating, ground tilting back inwards, kind of sagging, showing that that is not involved in any of this pressurization and action at this point in time. Just to reassure everyone, that's part of the equation as well, looking what's happening. And here's our SO2 for the last month, which once again is affected by the scale in tons per day from 140 to 80. These are all low values for the volcano. So you see a big range through here, all across here, and it looks kind of scattered. But these are all essentially really low values. We're at the low end of low here recently, the last couple of measurements here of SO2. But let's zoom it out to the last year to really put this in context. Here is 1 year of SO2 for the last year. Eruptions can reach up to 70, 80,000 tons per day, like happened here in June earlier. And after that first burst of lava and gas comes out, things back off pretty quickly within the first few days or weeks. And now we are basically right here in a very close to zero line in the context of that, right? So it's very low values compared to what we actually get. And the fear of gas, of course, is that no matter where you live, there's a possible gas impact when a volcano starts erupting again. And so we'll likely have another one of these jumps up to somewhere really high, and then it'll tail back off again whenever that activity does occur. So just noting where we are at this point in time. Once again, here at the low end. And you can see whenever these spikes occur, there's one right there, June, January. That's where we have these earthquake counts for the last year, building up, then collapsing, building up, and then collapsing. And that's what we'll expect to see here as well, building up, and then once it finally collapses, that'll be the eruption there. For GPS, there's that right end of the plot, and the earthquakes, right end of the GPS right there as well. If I zoom it in, there's that June eruption and relief there. I'm sorry, that's not June. That's back in January. That is a June eruption. That's June, and then January is back over here, that little one. And what you can see is that it's still rising this line. So the sides of the volcano are still spreading apart, but it might be doing it slightly faster. That line compared to that line. Right? There are times where it seems like it varies, right? So it's not a steady thing necessarily, but it does seem to be extending extra fast here as well. And just showing another one of these signs of the volcano still swelling as it pressurizes. And at Pu'o'o, down on the rift zone, the opposite pattern, contracting still. We saw a little bit of this extra noise in the data, but you can see now more clearly, seems to be continuing its regular pattern. And so those little adjustments, whatever was happening, it's sorted itself out by now. And onwards we go. So there's our 1 year blown out plot. For the last 5 years, to kind of round this off, here's earthquakes for the last 5 years, not counting the collapse events. So to reset ourselves, earthquakes per month, the scale goes to 4,000 from 0. So you see that following eruption 2018, we were at levels of upwards of 2,000 earthquakes per month, settled down somewhere in the range of 1,500 to 2,000 earthquakes per month for much of the following year or so, right through there, right? Then it builds up here in late 2020, October 2020. That leads to the December 2020 eruption when it collapsed. That eruption lasts until May. Low values, builds back up to September 2021, where it builds up to erupts again in September. Low values from September all the way through the end of 2022. There was this interesting extra cluster here, but that might be a Pahala cluster if I recall, perhaps. So low values all the way through until the end of 2022, when eruption actually kind of weans itself in response to Mauna Loa erupting. And then come January, earthquakes back up, they collapse back down. Here, January, February, eruption's ongoing in February. Eruption only lasts that 1 month and a half, 2 months or so. Earthquakes climb back up to June. Eruption happens in June, climbs back down again. So there is that interesting pattern of the last 5 years. This is all what's happened since the 2018 collapses. To kind of just reset ourselves here once again. And in GPS at the summit, it's been fairly straightforward. Starts off spreading slowly, a little bit more quickly, a little bit more slowly, a bit more quickly. Eruption, sags, recovers. Eruption, sags, recovers, and keeps swelling. It's standard for this thing to swell. Another eruption, sags, another eruption, it sags. And you see that's the pattern of what it's done. There's 4 eruptions we've seen. 1, 2, 3, 4 at the summit following 2018 popping up here. And note that the rate of increase here that we're seeing right now, right? Not just right now, but since before the June eruption, going back to the beginning of or following the January 2023 eruption, has been fairly fast here. This rate right there, right? You can see it's clearly faster than a rate prior to that. So it looks like we're in an extra gear when we look at all those deep Pahala earthquakes, big earthquakes happening, and maybe that's a supply rate kicking in the extra flux through there. Maybe this is part of it right here, right? Finally reaching the surface area and causing it to bulge extra fast here much of this year so far. So whatever happens is all happening at a higher rate now than it was last year. And that's something to keep in mind as we try to compare this eruption to previous ones that we've seen here at the summit. The rift zone has been a very different, also a very interesting story. So following the end of the eruption in 2018, you see the rift zone actually starts spreading. Sometimes a little faster, sometimes a little more steady, a little faster, a little more steady, a little faster. And this is the era when at first it was bouncing back from the kind of recovering from that eruption of 2018 and all the sagging and adjustment of the land. A big 6.7 earthquake moved the land out of the way a whole lot. Magma came and refilled it and pushed on it. And so following all of that, the volcano then had a chance to kind of settle from all the magma flow and from the earthquake and the ground's all moving. But that seems to end fairly quickly here. And it does seem like magma does reoccupy the East Rift there at Pu'o'o from this period following the eruption all the way until mid 2020 or so, right? So it's kind of filling both the rift zone and the summit. And around September 2020 is when we saw the summit start to really inflate and build towards its eruption in December 2020. So once the summit takes over there, we actually heard reports early on in that eruption that there was backflow, that the pressure in the East Rift Zone was flowing back towards the summit. And as a result, the rift zone began to sag. And you can see that pattern has been the same ever since 2020. The whole last almost 3 years now have been contraction for the East Rift Zone of Pu'u'o. And that follows that extension era of that first couple years of that window. And not quite clear if that was magma coming in through the upper rift zone area itself or something deeper like the deep rift zone. All that's still to be determined in the future. But that is all fairly agreed upon now that there was some rebound and refilling in some fashion and a re-extension of the rift zone up until mid-2020. And since then, it's been much quieter. So you might consider this entire era post-2018 eruption all the way to 2020, kind of this recovery phase of like still not clear what it's going to do. The volcano is refilling. It hasn't quite pushed to the limit where it has to make a choice and take a fork in the road one way or the other. And when that actually happened here in 2020, it shows a summit. And since then, it's been steady down for the rift zone. So I would put it that way, that really this phase of recovery post-2018 in the rift zone lasted about a couple of years there. And then since then, it's been quiet. Right? Interesting to note there following that end of that 5-year window. So that's all of our monitoring comparisons. I think it is important for us to go back to our source, of course. All this is building on data from the USGS Hawaiian Volcano Observatory. The reports indicating this elevated activity began on Monday with a special status report that came out at 2 p.m. The volcano is still at alert level advisory, aviation color code yellow. Dan and I joke this is now yellow plus, right? Because they've switched from having just weekly updates to now having daily updates. So Monday was essentially the quasi first one with a status update. Volcano is not erupting. However, Kilauea summit is currently exhibiting signs of elevated unrest. No unusual activity has been noted along Kilauea's East Rift Zone or Southwest Rift Zone. Earthquake rates beneath Kilauea summit region have increased from an average of about 20 earthquakes per day to over 40 earthquakes per day during the past week. Ground information rates are also high at the summit of Kilauea, similar to conditions before the June 7th, 2023 eruption. So they actually call out similarity to the previous eruption. This week's earthquakes peaked at 100 on Sunday, including a magnitude 4.3 event that was felt widely. And on the side, we've explained how that's not directly related to the magma there, right? You guys know the context. Most of the earthquakes were smaller magnitude 2 and occurred at the 0 to 2 kilometer depth beneath Kaluapele, Kilauea caldera, but also extended northeast towards Kilauea Iki crater and along the southern end of the caldera. We look at those patterns as well on the maps. Right? The increase in seismicity at Kilauea summit yesterday was accompanied by a brief increase in the rate of ground tilt, which was still since returned to a steady state. We've looked at that as well now. Gas emissions remain low, reflective of the current lack of activity, of eruptive activity at the summit. These observations indicate that magma is accumulating beneath the surface of Kilauea's summit region. The elevated unrest suggests an eruption at Kilauea summit might be possible with little to no warning, but there is no sign that an eruption is imminent. Another aside here, we have heard from scientist in charge Ken Han himself that this new pattern seems to be not a whole lot of warning of imminent eruption, but more this general elevated background. And once that happens, it could go from stop to erupting within 1 or 2 hours, is what we've seen in the last couple of eruptions here. So none of that's surprising. We're kind of pressurized, but it's not going to go somewhere random. It's going to happen all at the summit. That's how we can tell the pattern is that it's all within the summit context of what's been refilling. And once it's made that, once it took that fork in the road and it's been refilling the summit ever since 2020 there, that's what we've seen. So beginning Tuesday, August 15th, HVO returning to daily updates at Kilauea, aviation code and alert level unchanged. So that was the first update on Monday. There was one on Tuesday as well that came out. We'll just highlight the changes there that are different. They do note over the past week, there were 467 earthquakes of magnitude 3.2 and smaller occurring. That's an increase rate from before. They noted a single 4.3 again. Net inflation, more rapid inflation on the 13th. SO2 rates are still low. 86 tons per day is the most recent measurement 1 week ago on a 10th. No lava, no changes in the rift zone. Right, that's the hazards. I should mention here, right, it's still the gas. However, when eruption does begin, then you can have extra VOG, and that's noted in here somewhere as well. So that was Tuesday. Let's go to Wednesday, not erupting. However, they note yesterday, so this is referring to Tuesday, beginning at 7:30 a.m. and lasting for several hours, a swarm of approximately 50 earthquakes occurred at a depth of 1 to 2 miles, 2 to 3 kilometers below the surface, over 1.2 mile or 2 kilometer long region directly south of Hale Mountain crater. The swarm was likely caused by a movement of magma in Kilauea's South Caldera region, and is a process observed consistently at the summit. Some altimeters showed no appreciable inflation associated with the earthquake swarm. Elevated seismicity decreased following the swarms and remained steady, but still elevated compared to the previous week. And then kind of restating what they said in the previous days update all through there. So that was the flare-up, we'll call it, on Tuesday. And then the update from today, Thursday, August 17th, does note no appreciable continued inflation and earthquake counts have decreased following yesterday morning's earthquake swarm. However, still elevated above recent background. So quieted down a little bit today, but that's the pattern there. Maybe a little bit still of start-stop, but happening there. Yeah, I'd be surprised if it doesn't keep at high levels most of this following week as well, until it actually is ready to erupt, whenever that may be. So let's turn now to some observations. There's not a whole lot of these. We haven't had a whole lot recently when a volcano hasn't been erupting. Field crews are out all over the place. There is photos released from the USGS of the field crew on Samoa. I'm not going to show you guys pictures of just Samoa coastline, but that's out there if you're interested. On Kilauea, you can see images of HVO field engineers surfacing the instrument. This is the Uekahuna tilt meter, they note, which here in the caption, you can see, looking here, there you can see the electronics in a case that goes inside this big, see that there's an outer case, there's an inner case, right? That this one goes inside of that one. And you see they got it opened up so they can check all the wiring in there. But they note they visited the Uekahuna tilt meter station. Field engineers serviced the instrument, which was experiencing temporary data outages last week. So we saw that in our tilt plots, and there they are on the spot fixing them. And also they note HVO field work in Kilauea South Flank, July 26th. So there they are in Kilauea South Flank. Interesting pattern there. There is an upper slopes, and here is the fault scarps of these big normal faults, these big slumps that allow this ground that's piling up kind of slides down from its own weight, and this side towards the ocean over here, nothing holding it in. So slow, gradual slide. This is the area of that Helena slump surface area and the deeper landslides that occur below there and all the topography offshore. I'm not going to talk about that today here, and we've talked about that in the past. Helena slump being a different thing than is normally bandied about on YouTube. But in any case, these are the areas where the volcano is adjusting, and that's the shape of the land sliding off there. There is a field crew hiking the Helena Trail, and they note they are in search of tephra deposits from one of the Kilauea's largest explosive eruptions. Tephra from the 900 CE age eruption can be found within soil that had developed in low spots between lava flows on Kilauea's south flanks. USGS photo by Drew Downs. And here zoomed in on a geologist who is digging. It's hard to tell exactly. They have a little hole dug in here, right? And they're actually documenting all the layers of soil and then collecting bits of tephra from each of the different layers within there. And their caption here, under the supervision of a national park archaeologist to ensure we would not disturb any cultural resources, geologists dug holes about 8 inches down into soil preserved in low spots between flows. Soil and tephra samples were collected, which will help geologists better understand explosive eruptions at Kilauea. Photo by Kendra Lynn. So hello to the USGS team there. And following on that, since they did put out these two images of that directly follows the Volcano Watch, which we did not cover last week because we were trying to abbreviate for the sake of Maui coverage last week. Here is last week's Volcano Watch searching for tephra from one of Kilauea's largest explosive eruptions. And they do note this era of eruptions that occurs. There's that same image of them hiking Helena Trail. They do note that the Uekahuna ash and Kanakakoi tephra were those two of the most recent explosive periods right? Because Kilauea does have eras of both effusive, that means lava coming out more gently, like now, red lava flows coming out of the ground, like oozing, or more explosive when it's really throwing ash and big blocks and giant rocks into the air as well. And so they do note that the Kīlauea is a younger 1500 to early 1820s CE, right? That's one of the younger ones. But the older Uikahuna ash is that previous perhaps 1200 years of dominantly explosive activity there. Unfortunately, that actual type locality of the ash was a vertical section on a bluff on a wall of a caldera that collapsed in 2018 and was buried by rock slides. But there are that ash unit is widespread across the summit area, so they do have other areas to reference it, and the collection of samples from that one type locality as well. So they do note that the Kūlau Kuaiki tephra is a subset of the Uikahuna, erupting between 400 and 1000 CE. And that third part of the deposit, the K3, is the one that was one of the largest known explosive eruptions of Kilauea in the past several thousand years. So K3, one of the last largest known ones. That's a 900 CE event that they're referred to in another photograph there. They say that in that event, the eruption column likely reached 9 to 10 miles above sea level, 14 to 18 kilometers, for several hours. Dispersed tephra to the southeast, in an area larger than 65 square kilometers, 16,000 acres, from the summit all the way to Halape and the coastline 10 miles away, 17 kilometers away. So if this were to happen today, they clearly would have to close the airspace and all of that. This would be a huge event, unlike what we've seen in anything in modern times, really. The last time it was anything similar was 1924, and really before that, 1790 might have been, but neither of those as big as this one that is being studied here, the K3. So that's basically the why. They repeat why they're going out there. They do note what they can study of those samples they collect, right? They can assess the degree of tephra fragmentation, which is a proxy for eruption intensity and size. And they do that by measuring the shape and size distribution of the tephra grains using all their state-of-the-art equipment in the new tephra lab. They can measure the density to get at magma degassing. They have a picnometer and 3D scanner to help them with that, and microscopes as well to investigate how much is fresh versus recycled older lava. All that can help them understand the dynamics of that eruption, even if it was such a long time ago. So that is last week's Volcano Watch. And since that was Volcano Watch, let's make it say Volcano Watch there. And that's the first one, last week's Kilauea's largest explosive eruptions. But we'll also include this week's Volcano Watch, which is the most unusual Kilauea eruption, maybe 1823. So the background image here, you see there's the Great Crack. You see a HVO crew walking out along the fence line in the national park, which is a lot of times near the Great Crack here. And they're headed out to look at the 1823 eruption of Kilauea, which was actually the first one documented by Western travelers. That was a missionary, William Ellis, who had actually been to Tahiti and spoke Tahitian and came here, and it was similar enough to Hawaiian. He actually had a chance to talk to the locals and learn Hawaiian, and he's the one who asked them questions and wrote things down and has a lot of that early documentation seen through the missionary lens, of course, of early Hawaii here. So there it is, an image of that Great Crack area. And this grayer area is the 1823 lava flow that came out down there. It emerged from the Great Crack in 1823 at an elevation not that high above sea level. So it actually came from Kilauea summit area, which had a lava lake at its summit for some time prior to that. And Ellis describes walking up there after this, and he's seeing the big black ledge on the walls of the crater. So the crater was full of lava, and the lava level actually dropped as a result of this eruption occurring. And it likely went down through these cracks and didn't actually fountain so much as just kind of ooze out of the crack and start this big flow that went all the way into the ocean down in 1823. So the geologists are out in the field studying these old eruptions, collecting these old measurements, maintaining equipment. Can show you some of the key things, interesting things about the 1823 eruption is that when Ellis walked by there, he noted how the area was still steaming and in places too hot to walk on. But most of that eruption has lava flows that are less than 1 meter, 1 yard thick. So pretty thin lava flows from that eruption. So likely pretty fluid and oozed out pretty quickly and ran over area. And one other source of evidence for that is this area that they call the lava plastered cones. So lava plastered cones are areas of old volcanic features, the cones and spider ramparts and that kind of thing down there on Kilauea Southwest Rift. And these young flows, very thin flows, being able to actually plaster over top of these because they're flowing with such speed and are so thin they can actually go up and over in places, it seems like. Right? So there is an interesting feature. So a really fluid hot flow. And if it's that thin and it came out that hot and gassy, then it probably wouldn't have stayed hot forever. I mean, we talked about how down in Kapoho, the lava is going to be hot for a long time because it's over 100 feet thick. But if it was only 3 feet thick, then it would cool off fairly quickly. And, if you mentioned too hot to walk on, then the conclusion is that Ellis must have arrived there fairly soon after that eruption happened. And thus, they most likely believe it occurred in early to mid-July of 1823 as that bracket of time there. So that's pretty interesting there. They do note the Great Crack likely existed prior to 1823, but it possibly was wedged open further by a subsurface dike. They note prolonged dilation may have prevented the eruption from localizing at one vent, thus influencing the character of the fused lava. So what they're saying is like that crack might have been opening, and as it's opening, the lava is kind of backing up and just pouring out over the top, and then it doesn't keep building in one spot because the crack's still opening, so it kind of just keeps pouring down a spot, and the spot where it's pouring out keeps shifting down the crack as the time goes on. Is one possibility proposed here. They do note that it was actually so close to sea level that at the lower end of the fissure system, there were small steam explosions, phreatic explosions occurring there out of that crack as magma interacted with shallow groundwater. So there's a lot of interesting things happening there. But what they don't mention at all here is really the connection to the summit. And to me, it's not quite the same thing as 2018, but we saw a kind of a similar thing in 2018 where a very low elevation vent down in Leilani Estates, right? The lava was full at the summit and lava drained out. It came out. It wasn't, it's true, it flushed out a bunch of old magma at first that caused a bunch of fissures. But once that main bulk of magma came down, Ahu'aila'au, Fissure 8, it was such volume built up there that it was really, I don't know, it's like a standing wave all the time, like a fountain was kind of shooting up, but it wasn't anything like we saw in Kapoho of 1,000-foot fountains. It wasn't 1,000-foot fountains like 2,000-foot fountains like Pu'o'o or Kilauea Iki or anything like that, right? So interesting that maybe if you have, and we've discussed in the past how the collapse of the summit in 2018 went down to the same elevation as a vent in Leilani. So it really was like a draining out of the bucket and equilibration there of the level. So if the Southwest Rift opens up in a similar fashion as the Southeast Rift did in 2018, then what's to stop the magma in the lava lake at Kilauea Summit from moving down that Southwest Crack Rift, which is a Great Crack, in the surface shallower areas, that is the Great Crack, and going all the way down, wedging that thing open, and then popping out down there at the bottom. Be really, really hot magma coming from the summit area. And yeah, a lot of it must have stayed in a crack for sure as well. It's a long way for it to go down there too. So, but that's my little spin on it here at the end. I do appreciate the USGS going out there and sharing a little bit more about the Southwest Rift eruptions that don't often get quite as much publicity here. Pretty cool, and maybe someday we can, when we're not so busy, take a field trip out there as well and share something with you guys more on the spot. But we'll have to wait till we get more donations and more staff and free ourselves up for that kind of fun activity there. So probably not for a little while here, but appreciate the USGS doing it and sharing with us here on this week's Volcano Watch. All right, so before we wrap up with our community events here, let's touch base with Mauna Loa quickly. not a whole lot's changed in Mauna Loa. Here is summit tilt Mauna Loa, still increasing with variations daily and a little bit more on a monthly level here as well. So pretty subdued. Earthquake rates are still pretty low. Earthquakes per day are maxing out at 7 as the highest value here within the last week. Looks like something dramatic's happening. It's only 7 earthquakes, so nothing to be alarmed about. For the last year, it looks like this. Here we are at a very low end. This is a build up to the eruption in the end of 2022 from October to November. Then over the last 5 years, here we are once again. There is that buildup for 2022. In the previous 5 years of buildup, we're still at the lowest levels of earthquakes anytime in the last 5 years. So pretty quiet there in Mauna Loa. However, the interesting thing is looking at this map of 1 month earthquakes at the summit. These ones are colored by depth. The blue and purple ones here, these deep ones we mentioned early on, still happening under Mauna Loa and a little bit southwest of the summit caldera there, deep down. Here it is in cross section, depth around 40 kilometers there, looking at 25 miles or so, right down there, disconnected from all the surface stuff. And here we are, depth against time, and you can see they were happening more earlier in a month, a little bit more sporadic since then, but certainly a few events here within the last week down in that deep part of Mauna Loa, still ongoing. So that is Mauna Loa. There's not much else to add on that. Still filling in, no real threats from it. And we'll finish up with our community updates here, which are unchanged, but all things worth reminding you of. First is that the EA public comment review period is still open until September 5th, 2023. This is for the EA for the Kilauea recovery roads down in Pohoiki and Kapoho. So we've mentioned that in the past. You can go to Kilauea recovery webpage and find this update and the links on there. So check that out. You still have some time, September 5th. The next thing I wanted to mention here, still ongoing, is we have an internship available at Hawaii Tracker, HVERI as well, in association with Beyond Press Club. So we're taking applications all month still. You have to be a UH-Hilo student. But if you are, go to our site or message us and reach out and we'll give you the introduction. You can join a team for semester credits, actually, and a small stipend as well, and learn what we're all about and help us out with possibility of further collaboration in the future here. So that is also still ongoing. And if you know somebody, UH-Hilo student, let them know too for us. Appreciate that, you guys. Finally, our August events at Hawaiʻi Volcanoes National Park. We are halfway through August already, so we'll skip through halfway of this program here. We'll note that we did attend John Vorak's presentation last week on Tuesday, but we have not posted it just in light of the Maui tragedy. That is going to be coming up at some point in the future here. It was recorded and we'll post it for you guys. So interesting. He talks about the plate tectonics theory as opposed to hotspots, the driving forces of what's moving things around on the Earth. If you guys have watched any of our hotspot series here ourselves, some of that stuff will be familiar, but he takes it in a little bit different direction there as he gets into his presentation. So I enjoyed it. I look forward to sharing that with you guys when it's appropriate here coming up. We also already had the in-person August 12th Uikahuna talk and performance by Kīlauea Young. Coming up, there is, as usual, coffee talk at Uikahuna. This week, it's Alison Yana, organic gardener, permaculturalist, and beekeeper. National Senior Day Kilauea Summit Walk, Monday, August 21st, 9 a.m. to 10:30 a.m. Meet rangers in the flagpole by Kilauea Visitor Center. And this one I'm looking forward to on Tuesday, the 22nd. This is the one that was rescheduled from last month when there was Tropical Storm Calvin. This is Don Swanson speaking about the HVO facilities at Uikahuna and the legacy of science conducted there in that building, as well as the Reginald T. Okamura building, the new wing that was added in 1985 there. So that's the 22nd. The following week is going to be not quite the same flavor there. It'll be a one-woman living history play, Nani o Kahuku, Relive a Day on Historic Kahuku Ranch. This performance adapted by Jackie Puolani Johnson. We saw her do a previous interpretation as well. This one might be interesting because Kahuku Ranch in that time had an eruption, and there are families who were stranded by lava flows during that event. Huge earthquakes, people having trouble standing, cattle falling over. So I'll be curious to see how into all that they get. And of course, Kahuku itself is available for visit all the time, Thursday through Sunday. Walking it past with Dr. Jagger, with our friend of the program, Dick Hirschberger. Also ongoing Fridays all month. Stewardship, other walks. That's all of our community events here for August. And that said, Dane, I'm ready to turn it over for you for some mahalos and questions, discussion.
Yeah, we really don't have much in the way of questions, but want to thank everybody that stopped in today. We rely on viewers like you to help share the message. The more people that see it, the more we get that accurate information out there, instead of the crazy stuff, with the Lena slump and whatever else the internet's throwing out there, Johnny-come-lately style. We appreciate everybody that's been here, the subscriptions and likes. That really does help with the algorithm. We don't have grants at this point, so I can go ahead and just plug our donation page again. That would be, I'll put it in the chat again. Support, I believe, or is it donation? But yeah, we're taking donations on HVery at the hvery.org/donate. I'll drop that in the chat somewhere. And we've been, it's really rough because we were trying to do this whole donation drive and all this kind of things and had these follow-ups planned and all that. Then the Maui fire happened, and now we're like, okay, well, so much for that plan. So now we're just, we're doing what we can, and hopefully we'll find some grant money. But that's where we are, and that's how you can support us, is at the hvery.org/donate. All right, we do have a question here for you. This one was...
Just let me jump in there. Yeah, I mean, Maui deserves all the help they can get. Help Maui if you possibly can, and if you can help us also, then that's great. But we totally get it. Yeah, and it's just how it is, and we feel for Maui and happy to support them how we can. I think that's going to happen in the future. Not quite much we can do from here right now.
No. All right, this one was from Nathan, who asked, have they installed any new instruments to replace the ones lost during the 2018 eruption, or added any new ones since?
It's been so long. It's been 5 years, Nathan. I think they did install some gravimeters early on down there on a down drop block. Nothing really recently that's been installed, but by installed, I kind of think of something permanent. The more recent initiative has been that mapping of the Pahala earthquakes with a micro seismic network and the vibrosize truck coming through here and then flying the AEM and all those kind of geophysical studies. So there's a lot of data that's been collected through various surveys. So as important, if not more important than the actual permanent installations of instruments, I think, are these extra surveys going on. And it'll take years for it all to come out, but there is a promise that this data could reveal a lot about Kilauea's plumbing system. We're going to see it with eyes new, even those of us that are expert in it. It's going to be really, really something amazing to behold when it comes out. So otherwise, down drop block, I think some have been replaced. I don't know much about anything in Puna. I think most of the issues.
The cameras are the real thing that they've excelled at. They've added a bunch of new cameras. They've added the live camera. The temporary cameras are also more. There's more of them now, and they deploy faster, it seems. Things along those lines have improved. There's also the issue that the difference between what they have out there, and what they're monitoring, and what that they post, what makes its way to the public facing website, essentially, because those are two different things. So they might have added some sensors and things like that we don't have access to, essentially. And it's not for them trying to hide anything. It's more like just nobody updates the website consistently with that kind of stuff.
Yeah, and really, yeah, updating the website's the thing, right? Because along those lines, Nathan, like even instruments that they do have, like most of them are not updating the website as it is already. Like nothing at Mauna Loa is updating the website, pretty much. I mean, 1 out of 10 maybe,
Right.
and very little on Kilauea. So I'd be happy if they just got that stuff back in line. I hope, they have mentioned that there are new tilt meters somewhere on the plan with their recovery disaster supplement money. Haven't seen it happen yet. So my hope would be that when they install those, they'll upgrade the data connections to the website as well. But I'm totally just being hopeful and guessing on that based on what they've heard in the past. I haven't heard anything more so about new instrumentation recently, but good question. And
Yeah.
they're also flying to Samoa and checking instruments over there and that kind of thing, right? And we saw them fixing with Kahuna tilt meter. So that's what they're doing that we can tell.
One question from Skygate Ed, who asks, Mike wanted to know how they come up with the estimated weight of the SO2 output. Oh, that's a whole question right there.
Can you say it again, or can you put it on? I can't.
Mike wanted to know how they come up with the estimated weight of the SO2 output.
Okay, so yeah, what they do is they are trying to shoot some kind of measurement through the gas column, right? Or and what they've done in the past often is something like COSPIC or forward-looking infrared. So what they're doing, I'll explain how they're doing it now. Maybe it's the best way to try to get at this, right? So what they do now is they look for a really bright spot, like on an eruption site where there's a lava lake itself. In the past, it might be the sun. It might shoot up like through a cloud of fume towards the sun, but you can shoot it like at an actual event itself. And they're measuring the spectrum that's absorbed by the gases between the emission source and their collection instrument, right? So they have an instrument there that's trying to like look at that very bright spot. But as you know, when you look at something bright in a volcano that's erupting, it's not just sitting still there. It's kind of flickering, stuff's blowing in front of it, right? So you're kind of comparing the stuff blowing in front of it to the brightness of it behind there. But you're doing this across the whole spectrum. So they use that data combined with usually something like wind speed to figure out, okay, well, within that batch that we measured, here was a proportion, here's how much sulfur was coming out. So with this wind speed across the entire day, here is a volume of gas coming out. So that's usually how they do it. It's like some kind of, they take like a snapshot measurement of the whole area within a fairly short time if they can help it. And then they'll kind of project that to the whole day, right? And that's a tons per day value there. They're not measuring it across an entire day and then adding it up. They're doing it over likely a 1 or 2 hour period, I'd imagine, and then synthesizing it from there. So that'd be a great thing if we have a chance to ask a USGS HVO gas scientist sometime about their updated sampling routine. That'd be pretty cool to hear. But that's just a very, very simple take on it, Ed and Mike, on where that number actually comes from. They actually have to go out there and then essentially look at the sun through the gas coming out, or look at something bright through the gas coming out. It's possible for them to actually go across like a crater, like set up their own laser and then shoot it across the gas into a collector and then measure that also. But all depends on your setup, where you are, how far away you're shooting, where the stuff's blowing. And so it can get tricky for sure, right? That's why we've had questions in the past of, are you measuring every single plume coming out of the volcano? Or are you measuring the main one where most of the gas is coming out? Or how do you do all of that, right? We also know, we haven't seen these online yet, but we also have seen teasers that they have SO2 cameras, right? Where they actually can point it at the plume and detect concentration of SO2 just by the pixels on their camera. So yeah, that's something to look forward to, but there are a couple ways to do it there. And I'm not sure what exactly their mechanism of choice is right now. But yeah, that's a good topic of interest for us here.
Yeah, for sure. Well, thank you for that answer there, Phil. I think that'll do it for the questions. We are now approaching almost an hour and a half into this stream. which is past our normals, but we do stream normally at 5 p.m. Thursdays, Hawaii Standard Time. Unless something happens, that's the time you can catch us. If Kilauea goes, before then, you can probably catch us live at some point that day. And same with Two Pineapples, they will probably be out filming the thing most of that day as well if it were to pop off. We don't know that, nothing's imminent, but you never know. These things can happen pretty quickly. So yeah, but the one last thing is we are confident though it is going to be a summit eruption. USGS, there's no activity in the the rift zone, so that's why a lot of the guard is being let down essentially as to this eruption. It's going to be safely within the national park, just like the previous 4 or 5, whatever, how you ever want to denominate them, essentially the eruptions that have been taking place here.
Yeah, same pattern happening now, and yeah, unless the pattern changes, we won't be surprised.
Right. All right. Well, that I think will do it for me.
Yeah, and I appreciate that, Dane. Thank you guys for joining our discussion there, lively discussion in our chat happening today. Appreciate all you guys who are watching us live here, about 100 of you guys today. So mahalo. And we'll catch you guys next week, unless something happens between now and then that causes us to break in sooner. We'll be back at 5 p.m. Hawaiian time next Thursday. From H. Very, he is Mr. Dane DuPont. I am Philip Ong. Aloha, everyone.